In this video, we're going to be looking into uninformed AI search algorithms, and specifically we're going to be taking a look at breadth first search algorithm in this video. So in order to understand breadth first search algorithm, I've taken a small example and we're going to be making use of a queue and a visited array in order to traverse through this graph. So starting off, you need to assume a starting node and a goal node. In this problem, I'm going to be taking A as my starting node and G as my goal node. So now I can add my starting node onto my queue. So now the rule is whatever element is in the queue can be removed and added to visited in order for us to know that we have visited that particular node. So here I can take my A and remove it and add it to my visited. But before adding my A onto my visited, I have to do one thing. I have to check what are the nodes which are connected to A. In this case, it's B and C. So before adding my A onto my visited, I have to first add B and C onto my queue. Then I can add A onto my visited, like so. Now the next element in my queue is B. So I'm going to be removing B from my queue, then keeping it aside, then check what are the nodes which are connected to B here, which is D and E. So before adding B onto my visited, I have to add D and E onto my queue. Then I can add my B onto my visited. Now the next element in my queue is C. So I'm going to be removing C, keeping it aside, checking what element C or what node C is connected to. In this case, it is F. So I'm going to be adding F onto my queue. Then I'm going to be adding C onto my visited. Now the next element here is D. So I'm going to be doing the same thing, removing D, keeping it aside, checking what node it's connected to. So in this case, it's G. So I'm going to be adding G onto my queue, then adding D onto my visited. The next element here is E. So I'm going to be removing E, keeping it aside, and I'm going to be checking what node E is connected to, which is already not present in the queue. E is connected to G, but G is already present in my queue. So I don't have to add anything to my queue, so I can directly add E onto my visited. Now similarly for F, I'm going to be removing F, keeping it aside, checking if F has any node that's connected which is already not in the queue. But F is only connected to G, which is already in the queue. So I can directly add F onto my visited. Finally, we have reached G, where I can remove G and keep it aside and check what nodes G is connected to. In this case, G is not connected to anything, and G can be directly added onto the visited. So the whole point of this algorithm is for your G, the goal node, to be added to your visited array to inform you that you have reached your goal. So in this case, we have reached our goal because our G has been added to the visited array. So the search here is over.